So we will continue factoring trinomials. Don't forget a trinomial is a three-term algebraic expression, except these are a little bit different than the ones we did previously. These have the pattern ax squared plus bx plus c. The earlier ones had x squared plus bx plus c, where the leading coefficient was 1. Here, the leading coefficient can be something other than 1. And for these particular problems, it's going to be a value that's going to be greater than 1. So here we have factored the trinomial 5x squared plus 37x plus 14. And you can see right here, the leading coefficient a is 5. The middle coefficient here, b, is 37. And our constant c is equal to 14. Now when we factor this trinomial, again, when we factor it, it's going to factor into two binomials. Don't forget, when we factoring means taking an algebraic expression and turning it into a product of expressions. So it's going to come out to be two binomials. These types of expressions are known as quadratic expressions. So they have a specific pattern to them. So it's not as straightforward as it was in the previous examples where we could simply put in our parentheses and then fill in the values for x. It's going to be a little bit more sophisticated. And one way to be able to do that, and I think this is the best way to determine the factors, is the first thing we're going to do is we're going to take our leading coefficient a here, which is 5, and multiply that to our constant, which is 14. So we have 5 times 14. And 5 times 14 is 70. Now what we want to do is we want to come up with two values that when we multiply them together will give us 70. But when we add them together, it's going to give us 37, similar to what we did previously. So I'm just going to kind of look for factors of 70. I'm going to use a factor tree here, 2 times 35. Right? Those are factors of 70. And I'm just going to stop right there because 2 times 35 is 70. And 2 plus 35 is 37. So now what I'm going to do is I'm going to write this three-term algebraic expression, this trinomial, as a four-term expression. And then what we've done earlier, we had those four-term expressions, and then we grouped them. So I'm going to rewrite this using these terms right here. So I'm going to rewrite this as 5x squared plus 35x plus 2x plus 14. And I think we can agree that 35x plus 2x is 37x. And we've done that before. Whenever we factor trinomials, we go ahead and we collect like terms, but we're not going to do that. We're going to leave them expanded like this. Also, we can write this as 5x squared plus 2x plus 35x plus 14. After all, 2x plus 35x is the same as 35x plus 2x. Except I like to write it like this because when I group them together, I like to keep the terms with something in common. And I can see what's in common between these two, and that's going to be 5. 5 goes into here, and 5 goes into 35. And also what's in common here is 2. So if I group them together, remember when we group them together, keep the sign in that second group of the first term in that second group. So we'll get rid of this one here. Now, like we've done before, we'll factor the individual groups. 5x squared plus 35x. We could factor out a 5x. X plus 7, right? 5x times x, that's 5x squared. And 5x times 7, that's 35x. We could factor out a positive 2. X plus 7, and look at that. A common factor again of x plus 7. 2 times x is 2x, and 2 times 7 is 14. So since they have a common factor again, we just pull out that factor, x plus 7, and what do we have left? 5x plus 2. And there's our two binomials. Then when we multiply them together, we'll come out with 5x squared plus 37x plus 14. So we'll use FOIL again to go ahead and check it. X times 5x, 5x squared, x times 2, that's 2x. 7 times 5x, that's 35x. And 7 times 2, that's 14. 2x and 35x we can combine, so we have 5x squared plus 37x plus 14. And we'll find that those are the only two factors of 5x squared plus 37x plus 14. So I think we got it.